number 5 is the Q flow in one direction only. Okay, so these rules still apply, and we have one more, the 6, is the thickness is perpendicular to the shear flow direction. Okay. So if we have a structure, right? This is our Q, right? We know that this is our thickness. If we have the same structure, right? How come it can become an arrow? If we have the same structure and Q is in this orientation, then when that's the case, T is this thickness. Are we clear? Now, it's very, very important that I only have 4 more weeks with you guys. Start writing your what? Summary sheet. I repeat again, start writing up your summary sheet for this topic again. Okay. So you know how the thickness goes now. Okay. Now, the next thing that I'm going to show you is in thin wall analysis. Okay, there are 2 general configurations. Okay, there are 2 general configurations. And I think I have it here on last Wednesday notes. So if you could get the notes or the figure. So there are 2 types, or there are 2 configurations, not 2 types. There are 2 configurations. Okay, so you can see 2 different configurations. So one is known as the box beam. And the second one is known as the wide flange. Okay. Now, do you want to, if I show you this diagram, now this view is the cross-sectional view. Okay, so both share the same configuration. So this is Y, this is Z, this is rotation about X. Okay. Now, which one is known as a box beam? Anyone want to make a guess? The one that is enclosed, yes or no? So this over here is known as a box beam. And the one on the right is known as your wide flange. And most of the time, 95% of your structure, the cross section is either a box beam or what? Wide flange. Now, there's a couple student, a student came and see me, 2 of you came and see me regarding a structure looking similar like this. Where are you? You guys are designing something for some clubs. Where are you? They are not here today. They're too busy in the club. Okay. So a group of students, both of them came and asked me, a structure very similar to this. It's in fact their design. Now, how to calculate the what? The shear flow. And we get into that. Now, for this case, it looks what? Difficult, yes or no? But it's straightforward if you apply the rules that I teach you, okay? Now, I want you to, like, don't write anything, okay? Just watch the screen, okay? Because this is important. So what we have over here, you see all these dots on the box beam, you see all these dots. These are known as terminal. So this is terminal 1 over here. This is our terminal number 2. Okay. And I will declare this rule number 7. Okay. Is that at the terminal, the shear flow and shear stress are equal to 0. Okay. That's the first thing. Okay. So for box beam, you have 2 terminals. For wide flange, you have 1, 2, 3, 4. So you have terminal number 1, terminal number 2, terminal number 3, and terminal number what? 4. It's like Pearson Airport. Okay. And an important thing to take note is that the shorter the shear flow vector, the lower is the what? Shear flow magnitude. Okay. So watch here. Okay. If you look at the arrow close to the terminal, the arrow is very what? Short. Yes or no? When it's further away, it is very what? Very big. Okay. And then if you look at over here, likewise, the arrow are very small. So when it just leaves the terminal, the shear flow is very small. Okay. And then when it's further away from the terminal, the shear flow is very big, and so on and so forth. Okay. Now, the next thing I want to highlight to you that is important, and you guys say, Eugene, everything you say is important. Stop saying it. Okay. So the next thing is the major web controls the direction of shear flow. Okay. So what I mean by that, this is known as your major web. This is known as your major web. Okay. Those are known as your what? Your major web. So when it's above the centroid, right? It's above the centroid, Q flows away from the what? From the terminal. Yes or no? And then when it's below, Q flows towards the what? Terminal. Right? Most of the time, when you see diagram like YM, don't do that. Think like that. Probably not that. If you see something, you have to sit down. I know some of it like stove one. Okay, later on, when we have complex structure, this is going to help you define. Okay. What is the difference between thin wall and thick wall is this? Okay. I'm now going to highlight the difference between thin wall and thick wall. Okay. Now, this is thin wall. And then I'm going to draw the structure on the right-hand side. Similar size, I hope. Okay. Like what you guys have seen before in your homework. However, or not thick wall, I call it non-thin wall analysis. So for non-thin wall analysis, hey, remember I told you guys, our terminal is a what? It's a plane, right? So down here is also what? Our terminal. So when we design our shear flow, right? When we design our shear flow, it looks like this. Yes or no? Right? So you can see difference already, okay, between thick wall and thin wall. So if we were to consider at this line that I draw, not a good color, a green line. If we want to find the shear stress, that's not a very good example. If we want to find the shear stress over here at this line, the thickness where we're going to use is this thickness, right? The shear, the thickness is perpendicular to the shear flow. In thin wall analysis, right? If I want to find at a point down here, and this is our point alpha, okay, the thickness is this. Can you see the difference now between thick wall and thin wall analysis? Okay. Now, if we were now there is also somewhat similarities, yes or no? If we were to find the centroid, the thickness we're going to use is these two thickness over here. We have 2T, yes or no? For thin wall analysis, it's the same. Okay. As I mentioned before, there are similarities and there are also what? Differences. Okay. Now, the most important thing is this. Okay. When designing the shear flow, we have to comply to these rules. The major web controls the flow of the. So what is a major web? Okay. A major web is when you look at a web, right? You have the Y max, the major web was have a Y max, and also at the what? The extreme end of the what? Extreme end of the structure. Okay. So as you look over here, right? This is your Y max. This direction is your Y max. This direction is also your Y max. When this is the case, this entire section over here is known as your major web. Likewise, for this entire section is your major web. Okay. Right. So now, by knowing these rules, we are going to do something fun. Okay, we're going to do something fun. One,